derivative, we take the derivative of the outside and then multiply it by the derivative of the inside, also known as the chain. Here, we're going to be dividing by the chain. So we're going to do our power rule. We're going to find our thing that's raised to a big power. We're going to divide by the chain rule. However, just for a little bit of quick practice, we are going to do U substitution on this side. So on the front of this page, we're going to do U substitution on this side, and this turns out to be super easy U substitution. I'm going to show you how easy it is in just a second. On the back, mostly because they're telling you what the U is, on the back, you get to, first of all, cross off number 15 and 16 because they are separate, a little bit different, which we'll deal with tomorrow. And on this side, apart from those, we're going to try the divide by the chain rule. On this side. Which is what I learned, that's how I was taught, was just to divide by the chain, much like the derivative of like a 5 to the x. We took the derivative, we had to multiply by the natural log of 5. Integrate, we're going to divide by the natural log of 5. Okay, it's very similar. Okay, let's do a couple here on the front. We're going to just do U substitution on this side, and you can see that they've told us what the U is. So negative 3x to the 5th minus 1. So this whole thing is the U right there. Now, if we take the derivative, what would du be? Negative 15x to the 4th dx. Okay, so look what happens here. On one like this, we have our u. Here's negative 15x to the 4th, and there's the dx. Do you see it? It all cleans up like super nice, and we don't have to do any solving because everything's taken care of. So I can simply rewrite this integral as u to the 5th power, and then in place of negative 15x to the 4th dx, I can just replace it with a du. Like, it's completely cleaned up. All right? Could we do it the same way we did before? Absolutely. Okay? But it's all taken care of. Everything's got a new name, essentially. Does that make sense to you? Okay. And then, so u to the 5th, we're going to increase the power, which would be u to the 6th, and divide by the new power. I'm just going to multiply by the reciprocal instead. Don't forget the plus c, which then is, of course, 1/6, replacing the u, negative 3x to the 5th minus 1 to the 6th power, plus c. There's so many ways in math to rearrange things, and that's where we need to develop some sort of understanding of what needs to happen. What's the easiest thing to do, but it takes a lot of time to do that. Looking at number 2, again, we have our u already defined for us, and du is what? Dx. And again, negative 16x cubed dx is already in the picture here. And so I can replace those with du. It means the exact same thing. So I'm going to have u to the negative 5th du, because everything is taken care of there. Integrating, increasing the power, gives me u to the negative 4, divide by the new power, or multiply by the reciprocal. So I have negative 1/4, and then replacing the u to the negative 4th power plus c. So this is like super easy u substitution. almost like, do I need to do it? Use substitution, okay? And again, we're going to talk about this more tomorrow. Another shortcut way to do things. So maybe you're close to being there. On number 3, I would go ahead and rewrite this integral a little bit. We have negative 8x cubed, and then I would have negative 2x to the 4th plus 5 to the negative 5th power, dx, sorry. They've already told me what my u is, so du, the derivative, would be negative 8x cubed dx. And again, that negative 8x cubed dx appears already in my integrand. So I can just replace it, all of that, with a du. So I have the integral of u to the negative 5th power du. And we're going to go ahead and increase the power by 1. That'd be u to the negative 4. Divide by the new power. And replace my u. Let's see. All right, any questions on those? Totally easy, right? So now the whole question becomes, how necessary is it to do this step where I take something that's not too complicated, replace it with a u, and then have to resubstitute it back in? Is that really necessary? Can we deal with that in another way? And that's the divide by the chain. So when we're going to do this method, where we're going to divide by the chain instead, I still want to think about things in terms of u, which is why I wanted to start with u substitution. I need to see what thing is being raised to a power, because we have our power rule, which is pretty easy to do. So I'm going to imagine that that thing that I've circled is a u, and just pretend I'm going to integrate the exact same way we have been doing. I'm going to take that entire integral, negative 9x squared times the quantity negative 3x cubed plus 1, and now I'm going to increase my power by 1, so 3 turns into a 4. I'm going to divide by my new power, and because that thing that I'm increasing the power on has a derivative, I'm going to divide by that derivative, okay? So what is the derivative of the stuff in red? Negative 9x squared. So that's the derivative that we're going to divide by. And you can see when we do that, I'm going to put my plus c on so I don't forget it. I can do it all in one step. So I'm dividing by my new power. I'm also dividing by the chain, or dividing by that derivative, which is how we did everything yesterday, right? When we did the u substitution, we divided by that chain to get dx by itself, right? That's exactly what we're doing here. So again, this cleans up nicely. We're left with a 4 in the denominator. We can leave it like that if we want. Negative 3x cubed plus 1 to the 4th all over 4 plus c. With number 10, I have my thing raised to a power. And so I'm going to take my whole expression there, 12x cubed, that whole thing, 3x to the 4th plus 4. I'm going to increase my power. 4 becomes 5. I'm going to divide by the new power. And I'm going to divide by the derivative, or divide by that chain rule. What is the derivative here? 12x cubed. And don't forget your plus c. And then, of course, it cleans up pretty sweet in this case. This is a really easy worksheet. But and so, you know, when you're practicing these, you need to look really, when we have integrals, they get really complicated. We can take way more derivatives than we can integrate. So when you're looking at integration, you have to look at the whole problem first and kind of think to yourself, do I see my derivative? Because we have to we don't have like a product rule here. This isn't negative 12x squared times this whole thing. We don't have like a product like we do when we have derivatives. So things are way more complicated. But if we can see that I have something raised to a power, and when I look at that thing that I've circled, do I see my derivative? Then that's a good thing. All right, so we're looking for our derivatives. All right, so I have negative 12x squared times the quantity 4x cubed plus 2. I'm going to increase my power. That becomes negative 2. Divide by the new power and divide by the chain, or divide by the derivative, really. And so the nice thing here is that you get to choose which method you like best. And again, we're going to learn another one tomorrow. And hopefully you use a combination of all three, but we'll learn another method tomorrow. All right, negative 4x cubed plus 2 to the negative 2 all over negative 2 plus c. All right, that's it for me, guys. You can finish the rest, I think. Have a go, and that's it for practice. Do you have any questions for me?